Okay, now hypothesis testing is exactly the same thing. We know that the n minus 1 s squared divided by sigma squared follows a chi-square distribution with n minus 1 degrees of freedom. Okay? So in hypothesis testing, we are going to have what? The same thing that we used to have. The null hypothesis is the sigma square is equal to a hypothetical value, whatever it is. Equal or not equal is the alternative hypothesis. We may have sigma square is less or equal than hypothetical value against less, greater. Okay, the null and the alternative. Or we may have sigma square is greater or equal than a hypothetical value against that is less than the hypothetical value. Okay? In this case, we have a two-tailed test. We are again have a chi-square distribution. This is a two-tailed test. Okay? And this is alpha divided by 2, and this is alpha divided by 2. In this case, we have an upper tail test, and this is alpha. Okay, remember, when we have a one-tailed test, we have alpha. When we have two-tailed test, we have to divide alpha between the two tails. And in this case, we have a lower tail test. And exactly the same thing that we used to do. We are going to have a test value, and that test value is equal to n minus 1 s squared, where s is the standard deviation of the sample divided by the hypothetical value, okay, that we are comparing or that we are setting our hypothesis. Okay, that's it. And we test this value, and if the test is in the rejection zone, where is the rejection zone? This is the rejection zone. This is the rejection zone. And these are rejection zones for the two-tailed test. Okay, so if this test value is in the rejection zone, we reject what? The null hypothesis. If it's in the do not reject zones or fail to reject zones, we simply do not reject. That's it. That's it. Pretty easy, pretty simple. Let's do a problem. Let's do problem number 9. Okay, problem number 9 says, an automotive part must be machined to close tolerance to be acceptable to customer. Production specification called for a maximum variance. The maximum variance is maximum variance is equal to 0.0004. Okay, guys, we need to keep the production process under control, and that's why we are doing these tests. We need to know if the variances in the process is under control, and that's why these are the things. Okay, so the maximum variance is 0.0004. Suppose that we have a sample for 30 parts, so n is equal to 30. And turn out to be s squared is 0.0005. And we want to know whether the population variance specification is being violated. So we want to know, really, we want to know, and that is why I'm going to put this in the alternative hypothesis, is if the real population variance is greater than the maximums allowed, 0.0004. So the null hypothesis is going to be sigma squared is less or equal than 0.0004. That's it. This is how you formulate your hypothesis, because we need to know if the process is beyond the maximum variance allowed. Okay? And that's it. That's it. So we know this is a high square with, this is what? An upper tail test. Okay? They want us to use alpha equal to 0.05. Okay, so since this is an upper tail test, this has to be alpha, and this has to be 0.05. So what is this critical value over here? Go to the high square. How many degrees of freedom? 29. And what are we looking for? The 0.05, and that value is what? 42.557. Okay, so this is my critical value. 42.557 is my critical value, and I'm going to compare that critical value with my test value, and the test value is n-1 x squared divided by the hypothetical value in the hypothesis. Okay, so it's n-1, 29 times s squared, if they already gave us the variance, times 0.0005 divided by the hypothetical value, that is this value, 0.0004, and that is equal to 36.25. Okay, where is this 26.25 in this graph? It's over here. So it's in the fail to reject zone or do not reject zone. So my conclusion is do not reject the null hypothesis. So what is the conclusion? If we do not reject the null hypothesis, we are saying that it may be that the process is under control, is not out of control. The process is not, it's not beyond the maximum variance. The maximum variance allowed. Okay? So the process is still under control. Okay? And that is the conclusion. There is no evidence that the maximum variance is being violated. Okay? That's it. That's hypothesis testing about the population variance.